Hi everyone, welcome back to the channel, and today we're going to solve Leetcode daily challenge problem number 279, perfect squares. So we'll first check out the problem statement, and after that we'll look into the approach which we're going to use, and towards the end we'll see the code as well. So starting with the problem statement, it is given that given an integer n, return the least number of perfect squares that sum to n. Okay, a perfect square is an integer that is a square of an integer. In other words, it is the product of some integer with itself. So of course, you know the definition of what is a square, right? So if I say uh, 2 square, it means 2 into 2, and it will end up being 4. So they have given the same examples here as well. For example, 1, 4, 9 and 16 are perfect square. 1 will be square of itself, 2 will be square of 2, 3, 4 and so on and so forth. While 3 and 11 are not. Of course, you cannot have any integer, you cannot square any integer which will end up giving you result of 3, and same with the 11 as well, right? So we have to figure out, for example, in this case, we have to figure out minimum number of squares we will have to add together to get the number. For example, in case of 12, if we add 2 squares 3 times, so then we'll get 12 here, right? So this is what we have to find, and we will be using a dynamic programming approach to solve this question, and here is the approach which we'll be using. So I'll start with okay, so for the reference I have already mentioned a few of the possibilities over here, the best possibilities or the minimum squares which we'll need to make any of the numbers. And I'll also add one more thing. Worst case is, worst case for n will be to add one square n times, right? So this is this we should keep in mind. This is the worst case scenario, and this will be the formula which we will be using. So I'll tell you what we'll be doing, but before that let's just populate the values over here, taking the reference of this. So for preparing 0, we need not to consider this because it is not a valid integer. So for 1 we will have 1 square, like if we square 1 itself we'll get it. For 2 it is not possible, so we are adding 1 square 2 times. Okay, so we get 2 over here. For 3 as well, we will be squaring 1 3 times, so 3. Now 4 is a square of 2. 4 is a square of 2, so it just need one single square, right? So this is the 2 square. Okay, now we have 5. 5 is what? 4 square plus 1 square. Oh sorry, 2 square plus 1 square, right? Can we write that? This is the solution. Basically this is the possible way. So we will have two operations for this. Now if you look into it and see what we are doing over here, we are taking the reference of all the previous values which we have seen. For example, if I had to find possibilities to get 5, what were the options? Options were 1 plus 1 plus 1 plus 1 plus 1, right? Or we had 3 plus 2. Okay, 2 plus 3 will be same, 4 plus 1, right? So these were the options I had. If you go to get the the square which will need to make 1, the perfect square which will need to make value 1, you can basically access that here, right? So it will be what? 1 square plus 1 square plus 1 square 5 times basically, and the answer will be 5, right? Now we have 3 plus 2. Okay, so for making 3 we needed 3 perfect squares, and for making 2 we needed 2 perfect squares. So this will also end up resulting 5 perfect squares to make 5. Now in case of 4 we needed 1 square, right? The 1 perfect square I should say. Okay, so it will be 1 plus, for 1 we needed 1, so we have 2 as the answer, and this is exactly what we are doing over here. So for filling this this DP array. So this is my DP array, and I'll just erase all this and show you the resemblance of how this formula is working for us. So now let's say I have this much of this much of the DP array populated already. Now I want to find for I equals to 6. Okay, what I'll do, I'll run a loop for everything. So if you take the square root of 6, it will be somewhere around 2 point something something. Okay, so we'll take the seal of it and we'll run a loop from 1 to 3. Okay, so this is my concern range. Now we'll start with 1. Okay, let's take x is 1 now. Okay, take a temp variable and do the square of this one. 1 multiplied by 1 will be 1. I want to fill the value in 6, right? dp of 6 is equals to minimum of dp of I. Also, what you can do, you can initialize every index with the value itself. For example, I can do this, because as we saw, the worst case scenario is having the sum of ones n number of time. Okay, so this is it, and we have 1 plus dp of I minus temp. So my temp was 1 and I is 6, right? So can I write 6 minus 1, which will be 5. Okay, and this is 6. Now if you do this, do the calculations, we will get minimum of 6 and dp at 5 is 2 plus 1. Okay, because we have this. So the answer which you can have over here is 3. So this is 3. So we use the same formula, and if you try to verify this, see here we have 2 square plus 1 plus 1 square plus 1 square. So we needed 3 perfect squares to make 6 over here. And you can process for all x equals to 2, x equals to 3 as well. Okay, and this will be the answer, and we'll have to follow the same procedure for all the variables. And at the end, like if you are concerned, for example, n equals to 10. Okay, let me just clear this a bit, and we will just solve it for 10 quickly. Okay, so we have already calculated these values before, so let's see. For 7 we needed 4 perfect squares. For 8 we need 2. For 9 we need 1. Let's calculate for 10. Okay, square root, if you will take the square root of 10, you will get 3 point something, I'm assuming. Okay, if you will take, you will get 3 point something something. So let's consider x from I to 4. Okay, your I is 10 at the moment. X will consider from 1 to 4. Let's take x equals to 1. Temp will be 1 again, and for the value you want to fill it here, you will have minimum of dp value at 10 currently. Okay, which will be 10 by default, because of course, like, this is the worst case scenario, and 1 plus 10 minus 1, because I was 10. So I was 10, and temp, which is x square, is 1. So dp at 9 was 1. So basically you will have 2 here, like minimum value will be 2 for now, at least. I don't know about yeah, so it will be 2 for now, and you can check for other values as well. If you can get anything smaller than this, that will be your answer. But I think this should this should satisfy the requirement as well. And if you try to calculate, like So if let's just check out all the possible ways. So it will be 3 square plus 1 square. Then we have 2 square plus 2 square, which will be 8, plus 1 square plus 1 square. And what else? We have 6 plus 10, that will be almost the same. So yeah, these were the two possible ways, and this was the smallest one, right? So we'll be considering this one, and we'll put the value of this. Let's check out the code as well. So if you see the code, I have taken a base condition in which if your n is smaller than 3, you need not to do anything, and we can simply return n into it. And that's why I have initialized dp till my third index, or fourth index I should say, third value. And if n is greater than or equal to 4, then we are using the logic which we have. So what we are doing over here, we are running a loop from 4 to n plus 1, because this is not the last value in the range is not included. So this is what we are doing. And basically dp dot append goes with the worst case scenario. We are appending, or we are having the same number as the result, or the smallest possible number of squares you will need in the dp array. After that, this is the part where we are calculating the square root of I. For example, I wanted to calculate 10 in the explanation, the minimum possible perfect square we needed for 10. So we are calculating the square root of I, taking the seal of it. Okay, seal will give you the next integer if it is if it's a decimal number, right? So we are running a loop from 1 to that number. After that, we are taking a square of x, whatever value you are at, you will take the square of x. Of course, like if it is greater than the number you're looking for, or the I value of yours, you need not to check any further, and you can break the loop. Otherwise, what you'll have to do, you'll have to populate the value with minimum of current value, which will be initially, which will be your I itself, or minimum of current value, or 1 plus dp of I minus 10. Okay, so I minus temps come because it is possible. Temp is a perfect square, and we are looking for ways to reach the difference between perfect square and the current value. So this is why this formula works. And at the end, we are returning the value at the nth index of the dp array. Let's check out the test cases. And the test cases got cleared. Let's submit for further evaluation. And the solution got accepted. I'll show you just a sec. The solution got accepted, and we have performed average, I would say. So yeah, this was the solution, guys. Thanks a ton for watching other videos. Stay tuned for the upcoming ones, and don't forget to like the video and subscribe to the channel. Thank you.